Let's take a look at a more involved example. This time we have a Chromebook that slips out the window in room 226 and falls to the ground. I've never actually had a Chromebook slip out the window, but I have had a textbook slip out before, years ago, believe it or not. Its position is given by, in feet, is given by S of t equals negative 16t squared plus 64. We are looking to, A, see how long it takes for the Chromebook to hit the ground. Well, let's see here. That means that my position would be 0. Right, that's when this thing is gonna hit the ground. So I can solve this. 16t squared equals 64. Divide both sides by 16. So t squared equals 4. So t would equal plus or minus 2, but in this case 2 because time is positive. It's gonna take me 2 seconds for the Chromebook to hit the ground. B asks, what is the average velocity or average rate of change while it is falling? Well, if it's taking 2 seconds, I want to take care of the change in distance over change in time, which gives me s of 2 minus s of 0 over 2 minus 0. In this case, s of 2 is going to be negative 16 times 2 squared plus 64 minus s of 0, which is just going to be my 64 over 2 minus 0, which is 2. This gives me, let's see, I can get rid of those. 4 times negative 16, negative 64 divided by 2, or negative 32 feet per second. Feet per second, units make sense. Distance over time, that is an average velocity. That's a good unit for my velocity. And C, what is the instantaneous velocity of the Chromebook at time equals 1? What about at impact? Well, at time equals 1 and time equals 2, aka the time when we hit the ground, I'm going to need the derivative to find the instantaneous rate of change. So S prime of t would be, using my power rule, negative 32t. So S prime of 1 is going to be negative 32 feet per second, while S prime of 2 is going to end up being, plugging 2 in here, negative 32 times 2, or negative 64 feet per second. Bonus, what is the acceleration at time equals 0, time equals 1, and time equals 2, and why? Well, let's dig in. If S prime of t is the instantaneous rate of change, aka the velocity, that is how my position function is changing. How is my velocity function changing? Well, the derivative of velocity, how velocity changes, is acceleration, a of t. So what I'm really looking for is s double prime of t, the second derivative. If s prime of t is negative 32 times t, s double prime of t is going to be negative 32. Acceleration, units on my acceleration, feet per second squared. And why does this make sense? In a single word, gravity. This negative 32 feet per second squared is my acceleration due to gravity.